Okay, guys, so today we're going to be doing some notes for covalent compounds and what those are and how those bondings happen. So, the main focus is just on what a covalent compound is, how do we name it, and how do we identify those formulas. So, over the past couple of days, we should have been looking at Lewis dot diagrams, which, just as a refresher, your Lewis dot diagram is just a representation of the valence electrons for an element. So whatever element you have, let's say you have element X here, the dots are just representative of those valence electrons. So this would be one valence electron, two, three, four, and then anytime you have more than four, you go around and that's when you double up. 5, 6, 7, and 8. Now, obviously, 8 valence electrons, as we've talked about, is stable. 8 is happy. 8 is what all elements want to have. But not every element has 8 valence electrons. So what do? We make compounds between those elements. Compounds are what make elements happy. That's how we can get those valence shells to become full and stable. So covalent compounds, covalent is just a specific type of compound, and that's when two or more non-metals bond together. That's what makes a covalent compound a covalent compound. Co meaning that they're sharing valent electrons. Covalent sharing electrons. So covalent bonds are formed when atoms share those valence electrons, as opposed to another type of bond, ionic, which we'll talk about later. What this does is this allows atoms to become stable by again sharing their valence shells. So here I have a representation of two Lewis dot diagrams. Each of these have 7 valence electrons between them. This one has 7. This one also has 7. 7 valence electrons each. And the way that this would happen is that these two electrons would be shared between them. This becomes a shared pair. And now, because they're being shared, each of these atoms has 8. 1, 2, 3, 4, 5, 6, 7, and then this eighth one is being shared. Same thing for this other one. 1, 2, 3, 4, 5, 6, and 7, and then 8 on this shared one. So we have two shared pairs of electrons, or a single shared pair of electrons being shared between two atoms. That's what creates this covalent bond. They are now co-sharing valent electrons. If that doesn't quite make sense, go ahead and rewatch those Lewis dot structure diagram images. I'm going to draw another one off to the side here between two elements. Let's make them element A and element Z just to help out. Now let's say element A has 7 valence electrons. 1, 2, 3, 4, 5, I'll go this way, 6, 7. So element A has 7 valence electrons. Let's say element Z has 6. 1, 2, 3, 4, 5, 6. Now, in order to completely fill A's valence shell, what they're going to do is they are going to share these two electrons. These now become shared. And now A has a full valence shell. Z may not, but that's where we can add another element here. We can add another atom. Let's add another A just to make things even and balanced. Here's another A. 1, 2, 3, 4, 5. Going backwards again. 6, 7. We have another A. And again, these can now share and co-parent, if you will, these valence electrons. Now we're all happy, everybody's stable, everybody's having a good time because we are now full with our valence shells. So how do we name these? Because what we're going to be really focusing on for this unit is naming and writing the formulas for these covalent compounds. So how do we actually name these covalent compounds? It's pretty simple. We name them based off of how many of each element are present. Covalent compounds are named by their elements. What elements are in the compound determine their names. So elements that are further to the left are named first. Now remember, these are non-metals specifically. So don't think we're including metals in this group. These are going to be our non-metals only. So it's a small selection of elements, just so we don't forget. Elements that are further left are named first. Elements that are more to the right are named second. But the difference here is that their ending is changed to I, D, E. They're changed to ides. So, as an example, something like chlorine, element chlorine, CHLORINE, that ending would change to chloride. So it would become CHLORIDE. See, that ending has changed there. That's the only difference. So elements that are further left are named first, elements that are at the right are named second, and that ending is changed to IDE. It becomes an IDE. If the elements happen to be in the same group, won't happen to us very often, but the element that is at the bottom is named first. So whichever one is just lower in that group is going to be named first. That's all that really happens there. That shouldn't come up too often, and if it does, I'll make sure that it's very clear in the formula which one goes first. Now, in order to identify how many, because in this case, like I showed up earlier, we could have different numbers of each of these elements present in the compound. So how do we know? For a covalent compound, we're going to use prefixes. Prefixes are the identifiers for how many of each element are present. So we have a list of prefixes that we're going to use. We're going to focus on the numbers 1 through 10. Those are going to be our specific focuses for our prefixes, and these are going to be, I believe they're Greek prefixes. So please copy these prefixes down. I'm not going to ask you to memorize them. We're going to get a whole list of them that you'll be able to use for quizzes and tests. You'll have a list. But for right now, let's copy them down just to make sure we have them for practice moving forward. So first up, the prefix for 1 we're going to use is mono, like mono, e-mono, right? Just 1. The prefix for 2 is going to be di. Prefix for 2 is di. Prefix for 3 is going to be tri, like a triangle. Prefix for 4 is going to be tetra. Prefix for 5 is going to be penta, like a pentagon. And kind of after this point, after penta, it kind of makes sense with the shapes. Prefix for 6 is going to be hexa. 7 will be hepta. 8 will be octa. 9 will be nona, or nona. I prefer nona. And 10 will be deca. And those are our prefixes. So we'll use the prefix to identify how many of that element are there. So if there's 2, you would use the prefix di. If there's 8, you'd use the prefix octa. Now the only exception to this rule is for mono. We will only use mono on the second element to avoid some confusion. So we're not going to use mono if we only have 1 on the first element. That would just make things a little bit confusing and redundant, and we don't want to ever be confusing with our names. So here we have some examples. N2O5 is our first example. So my first way to go about this, and when it comes to writing the names, is I like to look at what are the elements. Let's look at the elements first. We've got an N and we've got an O. Well, I know N, that is nitrogen. So there's my first element. O, that's oxygen. So I've got nitrogen and I have oxygen. But if I remember, the second element, the ending is changed to IDE. So I don't want to write it as oxygen. I'm going to change that up a little bit, and I'm going to change it to ox. Ide. And we change that at the very last, or the second to last vowel, typically. Second to last vowel. Occasionally it'll be the last vowel, but again, this is where kind of say it and see if it sounds correct. If it doesn't sound right, it's probably not going to work. Like, I wouldn't want to make this as oxygide. That doesn't quite sound correct. Oxide sounds more correct. So usually it's the second to last vowel, but if it doesn't sound quite right, you can kind of make that assumption there. Once we go there, then we're going to look at these smaller numbers here. Now, these numbers we talked about before in our last unit that we had superscripts. These are subscripts. They are sub, like a submarine goes below. They are sub or below the middle line of your letters. So these are our subscripts. They tell us how many. This is how we know how many of each element there are. And for a covalent compound like these, that's going to be our key, is those subscripts. That will tell us how many. Again, when we get into our future discussions on ionic compounds, that'll be a little bit different of a story. But for now, we can just focus on our subscripts. And so we're going to match our subscript to our prefix. So here we have the subscript 2 on the nitrogen. It goes to the element in front. So the 2 goes with the N. Subscript 2, 2 is di. That's that prefix. So in front of the nitrogen, we are going to put di. So this becomes dinitrogen for the 2 nitrogens in the compound. For the oxygen, or the oxide now, since we're in a compound, we have a 5. The 5 goes with the element in front. 5, the prefix for 5, is penta. Now I can see there's this double vowel situation happening here. So what happens for double vowels is we will drop the vowel on the prefix itself. A and O, or double O's. Again, think of how it's going to sound. It can be a little bit confusing. You wouldn't want to say pentaoxide. That gets a little tricky to say. So we just say pentoxide, and we drop that A. So got a little squishy there. Pentoxide. Drop the A for those double vowels. And there we go. There's the name. Dinitrogen pentoxide. We have a couple more examples here, so we'll do those as well. Here we have an S and an F. So here we have S and F. Now this one here, we can see it does not have a subscript. We'll get to that in just a minute. Let's first just identify what elements we have. So S, we have sulfur. That is our element. So we would just start by writing sulfur. And then F is fluorine. Fluorine. Be careful not to write flowerine. That would be incorrect, and that happens a lot. So we have sulfur and we have fluorine. Now again, we have to change that second word, elements that are on the right and named second, we change the ending to IDE. So fluorine becomes fluoride, like the toothpaste. So we're going to change that ending. Let me get my eraser here. Change that ending. So it's no longer fluorine, and it becomes fluoride. Then we can now look at our subscripts. And here we can see we have a subscript for the F, but nothing for the S. Now, if we have no subscript, something that's blank, no subscript written, means that there's only one. Kind of like how in math you wouldn't write a coefficient of 1. You wouldn't say 1x, you would just say x. When we write our subscripts for our elements, we don't put a subscript of 1. Again, becomes redundant, becomes confusing. We don't want to do that. So this tells us here that we have one S. There's only one of them. This is that example of mono being our subscript, or being our prefix, Mono becomes our prefix, but we only use mono on the second element. So if we have only one of them, and it's the first element, we're not going to use the mono. We'll just leave that alone. So it's just going to become sulfur. We're only going to worry about the subscript for fluoride here. Since it's a subscript of a 2, we're going to look 2 is di. So this becomes sulfur difluoride. And that's it. Sulfur difluoride. Last up, we have H2O. Now, we all know that this is water, and some of these covalent compounds do have more common names that we will refer to them as. I will always try to give you that common name as well as the formula if I'm asking you to write the scientific name down. But let's do water here, for example. Now, water is made up of hydrogen and oxygen. At this point, we should all be very familiar with what water is made up of. We've talked about it a lot. So we have hydrogen and we have oxygen. But again, as we know, oxygen comes second and we have to change that ending. So it's not going to be oxygen. We're going to change it at the second to last vowel, which is the Y. Oops, I erased too much. And it will become oxide. Now we can look at our subscripts. We have a subscript on the H for a 2, but nothing on the O. No subscript there, which means that there's only 1. So we'll focus on the hydrogen first. There's a 2. Again, that subscript is, or that prefix is di. We're going to see that prefix a lot. So this is going to be dihydrogen. Then we look at the nothing for the oxygen. There's only 1. Now that prefix is going to be mono, and since this is our second element, we are going to use that prefix. So dihydrogen monoxide. We don't want a double O because that English language would make that an oo sound, monoxide. That wouldn't work out. So it's going to be dihydrogen monoxide. And there's the word. Going the other way is pretty self-explanatory as well. We're just going to take things and go backwards. So I will give one example of that down here. I know I didn't write one on the page, but just to give an example, let's say you're given an element that says, let's go with, let's say you're given something like tetra hydrogen di tetrahydrogen disulfide. Let's just say we have something like that. All we're going to do is we're going to break this apart into its pieces in the same way that we were just looked at going from the formula to the name. If we want to write the formula from this, we're just going to go the same process, but we're going to look for the formula, the elements first, then how many there are. So first I look at my elements. I've got hydrogen and I've got sulfide. This becomes the hard part here, is looking for what that element is without its IDE ending. But I can kind of figure out, well, the beginning of the word is going to be sulf. So I'm going to look for my element that starts with sulf. Again, these are all nonmetals, so I should be able to pick out pretty quickly which one sulf is, and that's going to be sulfur. So hydrogen, that's H. Sulfur, that's S. So I know that this is going to be H and S. Then I'm going to look at my prefixes. Prefix tetra, tetra is 4. So I know that there's going to be 4 hydrogen here. Now this is going to be a subscript, and this is the biggest mistake I see students make all the time. This becomes a subscript. It goes after the element symbol. So this 4 comes after the H, not in front of it. We'll get to what that would be later, but the subscripts go after the element symbol. Okay, same thing for this one here. Di, we know that di means 2. We should be very familiar with that one right now. So after the S, because we're referring to how many sulfides there should be a 2. H4S2. And this would be our formula for the name tetrahydrogen disulfide. Go ahead, get some practice with this. There's practice on Moodle, and there will also be a practice Google form available for you tomorrow. If you have any questions, email me or send me a message.